concepts when dealing with large data sets is having the ability to subset data and filter it to look at different elements within different columns and look at different sections of our data that are of interest to us. Now, Excel offers different dynamic tools that we could use to do such things, but some have limitations that we have to be aware of. So one of the first things that we could use to look at the subsets descriptively is actually use the filter built-in tool that Excel has. So we could go to our sort and filter button over here, press on filter. Filter here is going to produce these arrows next to the header row, where we could subset each particular column with whatever values it has inside to look at them separately. So for example, if looking at applicability, which we covered before, of what is true, what is false, which buildings and our data has the upgrade applied to it or not, when you press on the arrow here, we get both the true and false values both selected. So let's say I want to look at I want to see how many in total are true, so I can just select only the true ones. And we got over here 8,951 of 9,415 records found. So this can give us descriptively how many of the buildings in our particular data have the upgrade applied to. Or let's say we want to look at which ones we did not have. So we could look at false. So in this case, we have 464 out of 9,415 records that are found. Now, please notice here on the side that the indexing here has changed to only the numbers where, for example, in this false ones are the false numbers that we have, or the indices of where those values exist for the rows. So rather than having the regular 1, 2, 3, 4, 5, we have 16, 25, 50, 75. It's skipping and putting them up here. Now, we can be tempted here to just literally, after we filtered them, to go and apply some calculations quantitatively that are of interest to us. And so especially with ones where we have numerical outputs or quantitative outputs for our calculations. So things, for example, like if we go, for example, for our total energy consumption in kilowatt hours, our HP, our column. Now, if we try to go and take an average of HP here with this subset of data, and we put average over here, we would get 8,456.8842. But I want you to notice one thing, is that when we put that particular equation, the reference that it gave for the data, when we put that over here, the reference that we got for the data that we had was still HP2 to HP 9416, which effectively means even if we only filtered down to the 464 values, what is happening is that it was still, when we select the entirety of the column, Excel is still selecting all of the values, which means that the 8,456.8842 that we see here is actually representative of the entirety of our data and not our subset. This can be problematic, and if you're not aware of it, we can have numbers that can be incorrect in this case. So to actually solve this, one of the easiest things we could do is literally just going to our data after we have filtered it. So for example, here where we're looking at the false applicability, and clicking Control A or Command A depending on your OS, it's selecting all the data that we have and copying it by pressing Command C or Control C, and actually going to a new sheet and pasting it here. Notice now that in this pasted data that we have, our indexing is now correct, or as in the original, it's still following 1, 2, 3, 4, which is the correct sequence, and we only have here the 464 values that we have. So that would help us bypass the problem. To know what subset we're looking at, we can rename our sheet to applicability false in this case. And now if we go to our HP again, in this case, and try to do our averaging, what we would get is, let's click the average over here, is our correct new average, which is 7,100.64273. And this is how we solve this particular problem and bypass it. Please be cognizant of this, just so your numbers make sense once you're taking a particular subset out of the data that you're looking at. Now, an important concept to also know and be aware of is that when we were looking at weighted data, so in this case, as we had mentioned before, we have weighted data, but our weights are uniform. So here if we literally apply a weighted average, which is what we would do when we have weighted data, because they're all weighted the same, we would get the exact same average that we just saw on the, for example, for the HP column, our total consumption in kilowatt hours, which is the 7,100. But in the case that you want to, as a user, to change the weights and the importance given to a particular building, depending on what you're looking at and the community you're looking at, then we would have to factor those in and create a weighted average over here. Now, to create a weighted average, we can go to the side of our column, side of our data set, and just select an empty place for the cell. So for example, let's select one over here. Let's name it average energy consumption in kilowatt hours. And we would put weighted here just so we know that we're referring to this. And we can try to do it. Now, to do the average consumption, the weighted average in this case, we would use this sum product function that exists within Excel. So we could use sum product. And to use it, it's pretty simple. First of all, we will refer to our weighting column. Our weights exist in column C. And now, since we're using this new sheet, the subsets will only select the C's that exist within the applicability false. So C to C. And then we select where our data exists and what we want to average. So in this case, it was HP, which was the column we're looking at. And all of that would be divided by the sum of all the weights that exist in this particular subset. And now when we press enter, we get the weighted average. Now, the 7,106.4273 that exists here is because the weights are uniform in this case, but once you change them, this dynamic formula is going to allow you to calculate the weighted averages in accordance to whatever weights you assign for the data. Thank you.